Hi everyone, welcome to this talk on Istio use cases for PCF. My name is Usha Ramachandran and I'm a product manager at Pivotal. I focus on container networking and policy for C2C traffic. I'm going to be joined in this talk by Shannon Cohen and Shri Tumidi. They are also working on different areas of Cloud Foundry around security and routing. What we're going to be doing here today is just giving you an overview of the use cases that Istio enables and then take a deeper look at how we're going to adopt that to Cloud Foundry. So just a quick disclaimer before we start. A lot of the stuff we're going to be talking about is forward-looking, so it's just a standard disclaimer. Before I jump into the meat of the talk, I just want to get a quick show of hands. How many of you here have heard of Istio before? Okay, everyone. And how many of you have actually tried it out, deployed it? Okay, a few of you. So in this talk, what we're going to cover is firstly just understand a little more about microservice architectures and the unique challenges that they bring forward, and then we're going to do an introduction of Istio and Envoy, and then we'll get into a little bit of a deeper dive around security that Shri will be talking about, and then accessibility and traffic management that Shannon will cover, followed by a demo. We should have some time at the end for questions, so if you could hold your questions till the end, we'd appreciate that. So let's get started. So I guess everyone's familiar with this, taking your big monolith and then converting it into a bunch of microservices so that you can be more efficient. You might do this and be really happy, we took this legacy app and we made it into this microservice app. But there's really more to it. It's really just the start of your journey, where your microservice lifecycle is basically around, maybe you start with one version of your app, you might have to support multiple instances of it, you might have to roll out new versions of it, you might want to do some testing where, depending upon the user, you want to direct your traffic to one version of your app versus another version of your service. And then to complicate things even further, maybe you have to do this across many different clouds depending on your enterprise cloud strategy. So deploying a microservice within an enterprise is not as simple as just taking it from a monolith and making it into a microservice. In addition, as your architecture evolves, you're probably dealing with many different frameworks and languages. So you might start off, say, with decomposing a Java app, but then you might need things like Python or Node.js, or and also have a hybrid environment where some things are containerized versus some things are still running on a legacy platform. So there's a mix of different application types, different languages, and different teams may have different requirements for what they want to run. So this is every enterprise's favorite topic, right? Like security. Everything has to be secure by default. Everything has to have a zero trust model. There's defense in depth. And so a lot of what maybe an app developer has to do is worry about things like authorization, authentication, and then as an operator, you might have to worry about network policies or configuring policies for all your applications. So from that very simple, oh, I have this big thing that I broke it down, you might end up with a really complicated environment where you have different languages, different types of applications, and different types of security requirements as well. So let's take a look at the common challenges with microservice applications. And I've split this up into developer concerns versus operator concerns. Some of these are actually overlapping. So for example, because an operator maybe wants to enforce a security policy, the developer is burdened with actually implementing it. So as a developer, though, for your app, you're probably concerned about providing load balancing for it, making it accessible, doing things like circuit breaking, doing traffic management, health checks, retries, things like that. And as an operator, you're more concerned about the platform and making sure everything is encrypted, everything is secure, you have auditability, so you know what state your environment is if there is an audit. And metrics and observability comes in play here. With a few apps, it may be easy to really know what's going on, but once you scale to thousands of apps, how do you have that observability and have metrics for what's going on? And finally, the security, which I guess is a blanket for app devs as well as operators. So how would you solve this? It's possible today to do this with language-specific libraries. So you might, every single app developer may go and implement some of this themselves, but the capabilities across different libraries may vary. And as you can see here, like every single application is going to have its own type of library that's attached to it. So the challenges that come with this are basically around like feature consistency. So how do you know that you're going to get the same capabilities across all frameworks? And you might have really rich capabilities through Spring. I was just at the talk that was around Spring and Istio and comparing the two. So there's rich capabilities in some frameworks, but what about other frameworks? In addition, if every team is doing their own thing, how do you lay out architectural patterns across the board? And you end up with every line of business having their own tech stack, and as an operator, you have to kind of understand that. In terms of security, the app developer now has the burden of implementing security, and there's also perhaps not consistent standards across the board. In terms of visibility and configuration, again, because you have all these different varieties of architectures and tech stacks, you might have a really tough time figuring out how to apply patches. How, if there's like a security patch that has to go out, like how many different types of frameworks there are. So these are all just some of the challenges from like a do-it-yourself approach. So what you might do is use a sidecar where you're taking out the capabilities of language-specific libraries and extracting it outside of the actual service. And so the sidecar is going to provide a consistent way of perhaps applying policy, of doing traffic management, retries, and all these things. However, if you have your sidecar that's doing this for you, you might also want a control plane so that when you have a whole bunch of sidecars, you are programming them all consistently so that overall you're getting the capability that you want. And that, in a nutshell, is a service mesh, right? So when you hear the term service mesh, that's what you're talking about, a bunch of proxies and a control plane that's programming the service mesh to act in a homogeneous way. All right, so let's get into Istio and Envoy, which is a specific example of a service mesh, right? So what is Istio? From the show of hands, I guess everyone here should know what Istio is. So Istio is a platform agnostic service mesh, and it's been actively integrated into Cloud Foundry. Shannon and Sri will talk a lot more about how we're integrating it into Cloud Foundry. There's a very active open source community with a lot of contributors. Google and IBM are some of the main contributors. Lyft contributed Envoy, and then Cloud Foundry Pivotal has also been working on this on Istio. One of the interesting and very core parts of Istio is Envoy, and the rich capabilities provided by it actually do a lot of the magic that you'll see. There's an emphasis on pluggability and extensibility, and there's also a wide variety of capabilities that you get with it. And in the next few slides, we'll go through and see what those capabilities are. Just a quick overview of what the architecture looks like. So if you think back to the diagram which had the control plane and your proxies in the data plane, the control plane for Istio is basically three main components. One is Pilot, that does all your configuration for the envoys. The second is Mixer, that does a lot of the policies and the telemetry. And then Citadel, that does certificates and provides the envoy with certificates for your security. In terms of the data plane, you can think of it as 3 different traffic paths. So you have an ingress path, which will go through an ingress proxy, which is the ingress envoy. And then you might have service-to-service communication, which is more of your east-west direct communication. And that also goes through a service proxy, which is the sidecar envoy. And there's an egress flow, which will go to things that are outside of the mesh. And you could also apply policy going out through your sidecar envoy. So if you can see like this, the service mesh, it's really about providing a consistent kind of a behavior across north-south as well as east-west traffic flows. So how does Istio help with all those challenges that we spoke about? Firstly, it provides a very consistent platform. So you get a single way to do things. It's all declarative. So you can declare your policies and have them applied to different environments. You get consistent architectural patterns. And this is pretty important to us, that it's polyglot. So it's not just specific to a language or a framework. In terms of security, and we'll go into more detail around this, but it's providing you with a way to declare your security policies and take away the responsibility from the app developer to implement this. So this is a huge win for the app developer. And then in terms of visibility and configuration management, Envoy has a lot of telemetry information that it provides back to the mixer. Mixer is a pluggable entity, so you can hook into many different infrastructure backends through it. So why are we integrating Istio into PCF? If you think about PCF and the different abstractions it provides, the main goal is to enable developer and operator productivity. No matter if you're using CF push to push an application, or if you're using PKS to actually just deploy a container. And the problems that you see in both of these are very similar to the ones that we covered. So Istio is a really good fit for us to try and solve those problems. It's applicable to all application types, so it's polyglot, it's multi-cloud, and it's secure by default. So all of these make it a pretty attractive platform for us to adopt. And finally, it has a really big open source community. There's a lot of people who are working towards solving all these problems together. So I'm going to hand it over now to Shri. She's going to walk us through what we're doing with security on Istio. Can you hear me? Hello? Good? Okay, awesome. For some reason, when I'm doing this, I can never tell whether people can hear me or not. So sorry about that. Hello, everyone. I'm Shri Tumidi, and I'm the product lead for security at Pivotal. I've been with Pivotal for 4 years, but my background is in enterprise security, and before Pivotal, I was with CA Technologies working on a wide range of identity products and API gateways. So before we get into the details of the security features that Istio provides, I want us to look at the security principles based on what Istio is based on. So these are not principles, that have been formed now. These are principles that have evolved over time based on what has been happening in the enterprise security landscape. So the first one is secure by default. So Usha touched upon it, but why is this important? So as an enterprise, you are dealing with a lot of heterogeneity. You have applications which have adopted different language frameworks, different stacks, and it's very hard for the enterprise security team or the InfoSec team to basically enforce guidelines around security, because a lot is expected out of developers, wrangling with different application frameworks. So the first principle is that we can apply security policy by default without relying on application code, so that you get security as like a standard optimized thing for all your services and all your applications. The second thing is defense in depth. So I think you all are familiar with this.
So what defense in depth means is security can be applied at various levels. So, people who are familiar with API gateways, that deals with a lot of the layer 7 traffic. So you are applying authentication, authorization policies at layer 7, but then there's a lot that is happening beneath layer 7. You have transport authentication that can be done at layer 4, and you can have network boundaries and firewalls at layer 3. So just because you can do policy at layer 7 does not exclude you from, or it doesn't mean that you do not have to apply security policy at other layers. It's important because think about a breach scenario. So for whatever reason, your layer 7 has been breached, you should still have controls in place to protect you from that breach situation at the lower levels. The final thing is zero trust network. Now, as enterprises have evolved, the reliance on network boundary has thinned because, if you look at previous architectures, a lot of emphasis is put on hey, I'm running behind a firewall, I'm running, as part of a trusted network, so everything which is part of that network can be trusted. But that's a very dangerous thing because in this world wherein you have things running in various clouds, you have things running in public cloud, that is not the case anymore. You cannot trust anything everywhere. So there needs to be, you need to basically assume that you're running in an untrusted environment and you need to verify everything. So it's essentially auth before access is sort of the policy. So every call that is coming in has to be authenticated and authorized before you do anything meaningful within your service. So Istio architecture from a security perspective, it's again the 3 core sort of components. So there is Pilot, Citadel, and Mixer. Pilot is responsible for pushing security policy downstream to all the sidecars. So the security policy can be in the form of an authentication policy or an authorization policy. It is Pilot's responsibility to push it downstream to all the sidecars. But there is more method to this madness. So for example, if you're talking about Istio running on Kubernetes, then there are different lifecycle events that are happening, right? So if, as a developer, you're using the kubectl to push an application or a service, the Pilot is going to see that, hey, a certain action has happened and push policy downstream to this new application. So it is watching for those changes in the mesh. The second important thing is Citadel. Citadel is actually a CA, and it is responsible for pushing identity to every single service in the mesh. So you can translate it to an application identity or a service identity. So this is an X509 cert that gets pushed to every single service in the mesh. Now again, this is also piggybacking on what's happening at Kubernetes API layer, and it's noticing that, hey, if a new application is pushed to the mesh, then it is generating a certificate on the fly and it is seeding it into the sidecar. Finally, the Mixer. So the Mixer is basically an extension. It gives you an extension point. So Istio is providing you, some capabilities with respect to security, but if you want to extend them, Mixer is the way to extend them. So it is a plugin model, and if you have external systems which can do more finer-grained policy, or if you have external systems which can deal with, metrics, monitoring, observability-related aspects, you can actually use the Mixer to plug in the mesh to that bigger system. In addition to that, you will notice we have the ingress proxy and the egress proxy. So the ingress proxy is a place where you can actually apply perimeter policies to, in addition to policy that applies at the mesh and at the sidecar in the mesh. And egress is for the opposite way. So if a service in the mesh is talking to an external service and you want to apply a policy on the egress, that's where the policy can apply. So let's talk about the first use case, which is service-to-service authentication. It's also referred to as transport authentication. So the certs that I talked about, which Citadel is pushing to each of the service in the mesh, it follows a certain naming convention, and which is driven by a spec called the SPIFFE. It is Secure Production Identity Framework for Everyone. Wow, I remember that. So what SPIFFE format is giving you is, it is setting the guidelines for how this identity attestation and identity provisioning takes place. So again, in the Kubernetes world, there is the concept of a service account, for example. So for every service that is pushed into the mesh, there is a service account associated with it. So with the SPIFFE format in place and the Istio Citadel in place, it is capable of issuing a cert which follows a certain naming convention, and it is basically validating that service account before it is issuing the cert to the service. So from a service-to-service authentication perspective, this is done using MTLS. So instead of the app developer actually going through the mechanics of figuring out how to negotiate the MTLS is negotiated between the sidecars. So you have the sidecars in place, and so you have a client-side envoy, which is basically negotiating the MTLS with the envoy on the other side, and this is all happening outside the boundary of the application. And there is nothing that the app developer has to do in order to get that feature. Like, there is no code to be written. But beyond authentication, there is another cool feature to Istio, which is an additional authorization check. So you can have a policy in place which says that, hey, is service A allowed to talk to service B? And the sidecar, which is sitting next to the service, will, on the outbound, make that additional authorization check whether it is allowed to invoke the service that it is trying to invoke. So in addition to MTLS, which is authentication, you get authorization too. Finally, policy scope. So, I've spoken to multiple security teams and InfoSec teams, and one thing that I hear is we need some policies to be pushed by default. So it's not something that you want to do it like on a per service basis, but you want to do it at like a higher level, probably at like a mesh level or for a group of services. So that's where the policy scope comes in. So you can have policy which says that, hey, I want MTLS for everything in the mesh, or I want MTLS for only a group of services, or I want MTLS for just a service. So you have that flexibility in terms of rolling out your policy. The next thing is end user authentication. So similar to service authentication, there is another use case is, instead of a service interacting with another service, you have an end user interacting with a service. So in this case, how do you validate an end user identity? So one thing that I was always confused in the Istio world was that end user identity is actually not something that the mesh acquires. You are expected to pass the end user identity to the mesh. So this is something that Pivotal is working with the Istio community on, is how do we actually standardize on the end user identity acquisition as well. Today, though, what is supported is if an end user identity is passed in the form of a JWT, which stands for JSON Web Token, so it is an assertion of an end user. So it contains information about the end user. So it could be user attributes, group information, so different things flow in the JWT token. So how end user authentication gets done is, when that request is received by the sidecar is actually going to validate that token based on the policy that has been applied. So end user authentication policy looks something like, hey, tell me which issuers am I allowed to trust? So an issuer is an identity provider, so someone who has actually authenticated the user. So that's what the issuer is. So in Cloud Foundry, our identity provider is UAA, for example. So we have been able to test UAA's tokens with the Istio mesh. So what that means is, so if UAA is creating a JOT based on an external authentication provider like an Active Directory or a SiteMinder or a ping, that token can be validated by the sidecar in the mesh, and the authentication policy can be enforced. There is flexibility to this policy as well, because again, you may have multiple identity providers that you need to trust. So you can set up multiple origins within the end user authentication policy. So beyond the basic service authorization that I talked about, there is more finer-grained authorization that you can perform both for an end user and a service interaction. So when you talk about authorization, you can go with two kinds of models. Like you can either go with like a role-based access control, wherein you're encapsulating permissions within a role, or you can go with something like an attribute-based access control, which is more dynamic in nature, and it draws information from like multiple sources in order to make a decision. But role-based access control has been widely adopted by the enterprises because it gives you the visibility in terms of clear-cut visibility in terms of who has access to what. So Istio adopted the RBAC design. That's what Kubernetes has also adopted for its platform security. So in a RBAC design, the way things work is you first of all define roles in terms of what is it that you're trying to protect, what kind of access are you trying to protect. So these roles are like groups of actions that can be performed on various services. So you are encapsulating that role. So over here I have an example of like a role which is allowing all methods to be accessed on a certain service pattern. So in Istio, you can either enumerate the services, or you can have a regular expression pattern. So both modes are supported. In addition to that, you can also do policy on constraints, like you can have, like you can check for headers. So either it's like a V1 or a V2. So you want to allow only access to like the version 1, and you can check for headers that way, or version 2. So you can do some like intelligent policy there. Now, the second aspect to it is, okay, I define my role, but who am I giving access to? So you actually have to tie a user or a service to that role, and that is done through binding. So you can bind a user or a service through the service role binding. Over here too, you have a lot of flexibility in terms of putting filters based on what you receive as an identity. So as part of the binding, you can actually put filters based on JOT claims also. So this is like a very flexible model, allowing you to sort of define and design your authorization. So, I mean, if you're familiar with, like Spring Boot and Spring Security, you know about annotations, right? So you can have annotations on methods, and those annotations basically, like are driving decisions based on a certain identity that has been received. It could be like a SAML assertion or a JOT token. So it's very similar to this, but the good thing here is you can do this for any language. So, like Spring, you can do it for greenfield applications, for example, Spring Boot. But if you have legacy applications, and which you have to deal with, you can do this all on the perimeter without having to change any code. Finally, observability. So the Istios, the envoys within Istios, they emit a rich set of metrics which can be basically siphoned off the service mesh into like different systems that can be plugged in through the mixer. So if you're using like a Splunk or a Datadog, think of like all these metrics that can flow into those systems for further correlation and analytics. And as I mentioned before, like if you want to bring your own policy systems, you can use Mixer model for that too. So in the community, I believe they've written a plugin for another policy engine called OPA, Open Policy Agent, which gives you more capabilities than RBAC. So if you want to do attribute-based access control, you can use OPA for that. So I'll hand it over to Shannon now for traffic management.
come for traffic management and stay for security. My name is Shannon Cohen, and I'm a PM for routing and load balancing in Cloud Foundry. And we started learning about Istio about a year ago, and I got pretty excited with the prospect of using it to deliver more quickly on customer requests we were getting in the routing product domain. I'd like to revisit the landscape and provide some context. A slide you saw earlier showed the three data paths, ingress, east-west, and egress. And there's a lot of components in those data paths. And I think of Istio as a control plane for remote controlling these agents we have, and providing operators as a way of managing consistently policies across large fleets of services. And when you think of it in that context, the data paths that you're concerned with become a lot simpler because you're only talking about components you control. So when we're thinking about in the use cases that I'll discuss to follow, we're only talking about we only need to worry about applying policy to these proxies. Another note, and to provide some personal background why Istio was very interesting for us is, as was mentioned before, there's a rich ecosystem that's a development community that's working on the project, but also Envoy is already battle tested and extremely feature rich. It's designed from the start to be API driven, and that seems to be one of the first proxies on the market that's available that can say that.
I don't think it's all.
The use cases that I'm going to discuss here are going to be familiar to you. Anybody who's developed an enterprise application will have had to think about these things. But the reason that we discuss them here is to show that the way that these policies can be applied is now more simple, manageable, consistent, observable, auditable. A note about the most basic responsibility of the proxies in the mesh is that they need to be able to map a service name to a dynamic set of destination IPs. Whenever we talk about service discovery, it's helpful to talk about a more specific context because there's layers and layers of service discovery, ultimately enabling an application to request a service name and that to be resolved to some destination. But for that to happen, the service discovery system has to do some service discovery also. And in the context of Istio, Istio Pilot is receiving all the config it needs to program the sidecars from some other service discovery system. And by default, that is the Kubernetes API, although that is evolving to use what's called the mesh config protocol and get its config from a new component called Galley, which will in turn get its config from Kubernetes API. But in the context of Cloud Foundry, this config is coming from the Cloud Foundry components itself. And we've developed a component called Copilot, which is aggregating all of that config from Cloud Foundry in a dynamic way so that Pilot can configure those proxies with that mapping between service name and destination IPs. Next most basic function here is load balancing. Obviously, as developers want to scale up or down their applications, those destinations need to be dynamically updated. And multiple load balancing algorithms are supported in Envoy. Interesting note here is that Istio, as a control plane for programming envoys, is constantly trying to keep up with the feature set of Envoy itself. And Istio currently supports only 3 of those load balancing algorithms. I'm sure that will increase. But useful note that even what Istio supports is a subset of what Envoy supports. In the interest of consistency, Envoy and Istio take an eventual approach. This is much easier to manage in a distributed context. And in addition to service discovery, two other ways in which consistency is eventually achieved is through health checks, active and passive. Passive health checks, if you aren't familiar, are decisions made when a request is attempted and failed. A request for a workload comes in and the proxy tries to make a request somewhere and isn't able to establish a TCP connection, for example. What should it do then? Should it take it out of the pool for some period? Should it take it out permanently? What's the thresholds for how long it takes it out, and healthy thresholds for when it returns to the pool? Envoys also support active health checks. So in between requests, they're doing health checks to all the services that they know about, and based on whether those health checks pass or fail, doing something about those particular backends with regard to the load balancing pool. The first feature that we plan to offer in Cloud Foundry using Istio is traffic splitting, or as we've been calling it, weighted routing. This is solving the use case of a developer wanting to roll out a new version of their application. And rather than managing the amount of traffic which is sent to that application using scaling or capacity, increasing capacity, they can decouple the routing rules from the infrastructure or their application capacity concerns. So rather than adjusting the number of instances of a new version of the application, they can configure the control plane to send 10% of all requests from all clients to a new version of their application. And I say all clients because I think this is a demonstration of the real power of a service mesh, is that a policy can be applied in the context of a given service, but enforced for all clients of the service. In this example here, the author of service A, represented by sidecar A, has decided that 25% of traffic should go to their new version. And similarly, the author of service B, represented by sidecar B, has decided that 10% of traffic should go to their version 2. But that policy gets applied to all client applications, so both versions of service A. There's a lot of flexibility provided in Istio for how to map these policies with requests. And we use the term matching criteria or a route to describe this. This is the combination of how do I identify a request to apply a policy to, and then the policy itself. And that policy might be, here are my services to send requests for that matching criteria. At its most basic, routing happens with a matching criteria of a host name or a URI. But in Istio, you can also apply these routing rules to schemes, HTTP methods, headers, cookies, source labels, and a lot more. And each of these policies can be applied using an exact match or a prefix or even a regular expression. So there's a tremendous amount of flexibility. A very simple example in Cloud Foundry, it's common to have one application managing path foo of a domain, but a different application managing path bar. This adds a tremendous amount more flexibility in that regard. TCP routing is also supported, so the proxies can decide where to send where to establish a TCP connection based on what port the TCP connection was established from a downstream client. And the proxies also support TLS pass-through, and routing based on an SNI host. So if the proxy is not actually decrypting or terminating TLS handshake, how does it know where to send the request without decrypting the payload? And SNI headers, originally used to decide which certificate to offer when many domain names were supported, can be used to make that routing decision. In this example here, the author of Service A has decided that when requests include a header that indicates it's from a mobile device, that they should send it to a different version of their application. And the author of Service B has decided that writes should be handled with a different application than reads. Rate limiting is a common request that I hear from customers, not only to prevent malicious attacks, but also just in the nature of healthy operation, making sure that you maintain availability. Again, this demonstrates the power of applying these policies through a mesh where you have control of all clients. In this example, the author of Service B has said that across all instances of their application, they only want to they should accept no more than 100 requests per second. Now, Mixer is one of the components that's receiving telemetry from all the proxies in the mesh. So Mixer actually has shared state for all traffic in the mesh. And when the proxy for Service B is receiving requests, it can call out to Mixer and say, should I accept that request? And it can get a response from Mixer that is informed by the requests that have been made by all clients in the mesh. Now this is really powerful. It's actually from the perspective of from a team who's been responsible for a shared ingress proxy that manages 250,000 containers. Shared state poses a large burden. And this pattern offers a lot of power to help with these use cases. Other limits that can be configured are concurrent TCP or HTTP requests. Another common responsibility that app developers and those responsible for microservices have to be responsible for are: how long should I wait for a TCP connection to be established? How long should I wait for an HTTP response? And if those behaviors don't act as I expect, what should I do about it? Should I retry? Should I return a failure to my client? Istio enables app developers to configure these policies, again, at all data paths: ingress, east, west, and egress. I'll call out here, though it applies to many of the other use cases I've discussed, that these policies can be applied for destinations also that are not in the mesh. Here we have an external service that doesn't have a proxy in front of it. But the sidecar, when a policy is expressed that when service A is calling this external service, it should only wait 5 seconds for a TCP connection to be established. The sidecars for service B or an egress proxy can apply that policy for you. A really cool feature, I think, of Istio is enabling app developers for troubleshooting or in the development process to simulate failure without any code changes. As an app developer, I would like to know how my client behaves when encountering a failure calling someone else's service. Rather than causing that service to fail, I can tell the service mesh to introduce a simulated failure, a timeout, or a response HTTP status code of some kind. And my sidecar, the sidecar for my service can return that error without a request ever being made to the real destination. A thought that's been developing in my mind as I talk with customers who ask in the context of Istio, I've got a strategy for an API gateway, or I use an API gateway. How does it play with Istio? And my hypothesis is that Envoy and Istio are an API gateway, and a pluggable one at that. In addition to the use cases we've discussed, security, auth, all these traffic management controls, you can add or remove headers, you can rewrite URIs, redirect wherever you like. You can even do scripted composable transformations. This sounds a lot like an API gateway. Again, you're familiar with a bunch of these use cases, but the power of the service mesh, I think, is enabling a consistent management of these policies across large portfolios of applications and in a homogeneous way for various personas, not just the operators and security admins who are interested in global policies or whether one workload can talk to another, but app developers themselves. So the admins can provide guardrails. App developers have the freedom of composing their microservices the way that makes sense for them because they can manage the traffic between them. A little bit about the current state of Istio and Cloud Foundry and where we're going. Over the last year, we have been working on fundamental integrations with Istio Pilot and Cloud Foundry, enabling dynamic routing of ingress requests. And as I mentioned, weighted routing will be our first feature. We actually have experimental support for that now, and I can give you a demo in a moment. We're also currently working on, or will very soon be working on getting the east-west traffic between workloads in Cloud Foundry, transiting those sidecars, and those sidecars being programmed so that the same kind of policies that can be programmed for ingress can also be applied between workloads. And Shree's security teams are getting involved to do user authorization. We're also thinking about not just using Istio for use cases within one Cloud Foundry cluster, but between Cloud Foundry clusters, between workloads in Cloud Foundry and workloads on Kubernetes clusters. There's already a very tight integration between Istio and Kubernetes, and we see exciting outcomes leveraging Istio to both manage security policy and traffic to allow workloads on those platforms to interoperate. Okay, I have a short demo. We don't have a CLI yet for this, so I'm going to use a curl to apply the policy change. But in this case, I've got a version 1 and version 2 of an application, and only version 1 of that application is associated with a production URL. Each of the versions have their own URL. So you can think of blue and green, and in addition to blue and green, you also have a production URL. And what I'm going to do in this demo is show that initially when I send repeated requests to version 1, that, to the production URL, I'm only getting responses from version 1. And then I'm going to apply a policy change that says I would like 10% of requests for this production URL to go to version 2. And then I'll make a bunch of requests to the production URL, and we'll see that 2 out of 20 requests are routed to version 2. In the initial version here, the weights are expressed as relative integers because currently there isn't an API that allows us to make a declarative policy across multiple applications, but that's coming real soon. Then the user experience will enable app developers to express these policies using percentages. All right. So here we see that a request for the production URL returns version 1 consistently. And I'm going to make a curl that says send 10% of traffic to version 2. And now you'll see that both versions are associated with the production URL. And over in the right, in a moment, we'll see, in the top right, we'll see now that 10 and 90 policy. Now I'm going to make a bunch of requests to the production URL. And I need to do this a couple of times so that for the policy to propagate to the ingress proxy. I think on the third try it works here. There we see 2 out of 20 requests sent to version 2 of the app. Okay, I think that's all the content we had. If you'd like to ask us questions, I think we have a bunch of time actually. And you can get a hold of us later on this Slack channel. Cloud Foundry is an open source project. I work with an open source team. The technology that we're implementing is available both in open source and will be soon in Pivotal distribution. Here's some links to some docs. Okay, I think we can take some questions. Shri, Usha, you want to join me here? I have a question here. Do we have mics for folks in the crowd? If you don't mind standing and shouting, maybe.
Sure. Bobby from Government. Quick question on the boundaries of Istio. Is it going to be within PCF only, or if we have external workflows today, could we integrate those into the mesh?
You could, and in a number of ways. So the Istio, you could add those services to the mesh by putting a proxy in front of them. Well, is there another way?
Yeah. There are some use cases around identity as well. So if you have legacy applications needing to interact with applications in the mesh, and there are token format mismatches and stuff, that the boundary is where you do those exchanges. So for incoming calls, if you want to apply security policy, you can do that at the perimeter. Also, in addition to doing additional things at the sidecar level. So same thing with egress. So on the egress front also, there is some amount of aggregation that you can do in terms of policy. So you may have like multiple microservices needing to interact as like one entity with like an external database, for example, and you can have one policy to make that happen. So you can have like some aggregation of at the perimeter for ingress and egress. So the egress stuff, however, I think is in still very early stages in the community. Ingress is where some work, I can see some work happening.
Couple of questions.
So I have a question on the Envoy, which is like a sidecar component to an app, right? So can we use, are there any use cases for Envoy playing a role of layer 7 security, like OWASP, top 10 vulnerabilities? Can it be used positioned in a way that it can act as a firewall to the application?
Yeah. So yes. So if you want to do OWASP top, yeah.
The question.
Yeah. Sorry. Yeah. Let me repeat the question. I forgot. So the question is, can we implement OWASP like top 10 policies in Istio, which don't require like potentially changing anything within the app code or framework? Yes. So you have the ability to do that, and if you already have a system that does that to some degree, you can plug it via Mixer. So you could write a Mixer plugin that could, basically intercept the request, do that additional processing, and give you a yes or no decision. So Mixer is a good way to bring them in initially, but if you want to do deeper integrations, then you need to work with the community to bring those features as core policies that can be driven by an Istio Pilot and the sidecar.
There was another question here.
Hey, yeah. So you mentioned there's like you can apply regex on the authentication overlays. You can also add custom code. So certain mature API gateways have metrics so that you can see if somebody wrote something that was like boneheaded or something else. What metric options do we have to see how well these policies are performing?
So the question is, there are like various policies that we are pushing to these sidecars through Pilot, and those policies can be pretty fine-grained in terms of the different regular expressions that can be applied. So what metrics are being, like collected and siphoned off. So my understanding in this area is pretty low around what is the exact mechanic, but I can say this: I believe there are like different points of interception in terms of like what policy got applied, right, and when did it apply, and is it like in works right now for a certain data path or not. So those metrics will be emitted, but then like you will have to write to some degree your own system to further correlate those metrics. So what we have to understand is, like the service mesh with Istio Envoy, with the Envoy, Citadel, and the other core components is giving you the framework to actually extend beyond what it is providing. So it's providing you like some basic capabilities with respect to security, traffic management, but it gives you the opportunity to extend them.
I'm happy to give you a link to some metrics for what Envoy emits, and they're so rich that from wearing my operator hat, I'm a little nervous about some particular proxies in particular roles emitting them all. Once the policy is applied, I think you can use your metric aggregation system to determine whether you're seeing persistent or intermittent failures as a result of that, and those. Whether it's Grafana or Splunk or whatever your aggregation system is, assuming that the app developers also have some slice of visibility, would be able to use those metrics to troubleshoot themselves. I'm sorry, he was first back there?
Sure. Christian from Malto. The question is, how is Istio being used in Cloud Foundry? Are you introducing sidecars, or are you replacing the routers, or maybe
So today in Cloud Foundry, Envoy is deployed in every container, but it's fulfilling a very limited purpose. It is terminating TLS from GoRouter for the purpose of encrypting that leg from the edge or ingress router to the containers, and to guarantee using application instance identity in those certificates to guarantee against misrouting. What we've been working on over the past 9 months or so is adding Pilot and a ingress Envoy, which would run in parallel to the ingress Go router and TCP router. And eventually, once we reach parity, or sufficient parity, Go router and TCP router would be deprecated.
Yeah, and there are also other integrations that are going on. So for east-west traffic, there's, we're going to use the same container Envoy that's already running and that's providing the TLS for route integrity right now, but also, fulfill some of the east-west capabilities of Istio using the sidecar Envoy. And then there's a bunch of like security-related features too.
Yeah, so from a security standpoint, we are looking at, to begin with, how can we enforce authentication and authorization policies. So we are starting off on that track first. And as I mentioned in the presentation, we are also going to be looking at doing token acquisition or end user identity acquisition in a standard manner.
Follow up on that, how does misrouting happen? You mentioned misrouting, right?
In the case of a failure in your control plane, whatever your system is, whether it's Cloud Foundry or other, you have a consistency problem. And if the control planes failed, then your proxies don't have the latest data. And if you have a container orchestrator whose decoupled responsibility is to keep applications up no matter what, your containers are going to be destroyed, containers are going to be created, you eventually have a problem of IP or port reuse, and your proxies fall out of date. So a request can be received and sent to what it thought was the right backend, but now it's something new.
When the transient state,
I'm sorry?
it happens with the transient state.
Exactly. It happens while, it happens either due to delays or temporary failures in your control plane. The proxies aren't getting the updates. We solve this by using TLS to validate the identity of every application instance in Cloud Foundry.
There can be a mix, right? In the transient state, there can be a version 1, version 2 coming up at the same time. Then how you resolve that conflict?
I'm not sure I understand. Will you try to say it another way?
So the application 1 is moved to version 2. Right? In the transient state, there will be application 1 with version 1 and application 1 with version 2. So will they have two different certificates at that time?
Yes, actually, every container in Cloud Foundry has a unique certificate. And so we're not just validating an application or even a version of an application. We're validating a very specific instance of an application.
George Smith with Authz. In one of the previous slides, you were showing application A, V1, and V2, talking that application B, V1, and V2. And the implication, my implication, is that A application were instances of this 3% request. But it looked like you were treating the B as instances and not as mini clusters themselves. Of course, entering, upgrading of the version.
Let me see if I understand your question. I did have a slide. I think it was maybe the one where I was talking about the flexibility of route matching, where I had an example where the request was coming and you wanted to go to a mobile device.
Or the one that was basically splitting the read to the right.
Right. I think I had intended that they were maybe the same code, but operating in a different role. I had another slide, I think, where I was actually showing two different versions of the application. I don't think that I had a slide where I showed multiple boxes that were actually representing different instances of the same version of the same application.
So my point is that obviously B1 and B2 are actually clusters. And
Oh, sure. Each one has multiple instances. Yeah.
you're actually still valuing the
Shannon.
load balance.
Just repeat what they say.
You're still valuing that splitting is occurring on the sender and it's still going to a load balancer for clusters.
No, it wouldn't need to transit a load balancer. Because
I'll talk more.
Yes, please
Yeah.
come up. I'm sorry, I misunderstood.
I guess there are a couple of different traffic flows that are possible where if you're going instance to instance directly, then you're not going to go through a load balancer to reach the destination. So the example, if I am understanding correctly, is actually showing that potential use case. But even if it did go through a load balancer, the policy is actually applied on every single instance. It's not applied at the overall level.
Envoy is your load balancer, basically. When it's used by the container with
Yes. Yeah. So the comment was that Envoy is your load balancer, which is true. There were a couple more. I think you had a question. Did you have a question?
Yeah, I have that question. So, I'm Jenny Zhang from Mastercard. First of all, what version of Istio are you guys trying to integrate? Is that a 0.8 or 1.0, 1.1?
I think since we're not using, or we're not suggesting that Istio be used or can be used with Cloud Foundry in production yet, we're still in development. We're working off a release candidate.
All right,
So we're latest.
All right, so do you have any, well, I guess at some point in time we'll have to talk about the timelines because we're looking at a Kubernetes, which is on top of the PKS. So I guess this is the two worlds, right? The Kubernetes and also the PKS. How these two is going to be talked together the service mesh, how that's going to work. So do you have any opinions on that?
So there were two questions. Do you want to repeat the questions? I can repeat the questions. So there were two questions. I guess we're talking about both PKS as well as PCF. What versions would we be running? And also, will it be the same service mesh across the two?
Whether it's the same service mesh is actually one of my favorite topics at the moment, and I don't have an answer for you. Our initial plan is that there will be in PCF a shared routing, at least a shared ingress routing service that will serve PAS and PKS and PFS and everything else, and it will be managed by Istio and Envoy. In the case where, if we assume that cluster users or PKS cluster users, or whether your K8s clusters are deployed with PKS or not, are installing Istio themselves on their K8s clusters, how do we manage policy across clusters, whether it's Cloud Foundry or Kubernetes, where you have this shared or system Istio, as well as the cluster Istios, and how those coordinate and who's responsible for those cross-cluster policies? That is the subject of much conversation, and I don't have a concrete answer for you yet.
Go ahead.
Quick question. What is the integration? Is there any integration with, I'm thinking F5 load balancers like GCP, right? NSXT. Is there any integration on that layer? So I get what you're saying. Inside the cluster, Istio is great, right? All these great things about inside the cluster. But the hard part for me working with customers is the integration with existing systems, right? So like DNS and load balancing and those type of things. Is there any plans, maybe not for us at Pivotal, but just in the Istio world for those integrations?
I've just started learning about the Kubernetes external DNS project, and I've been talking to some folks who are leveraging it, some customers, and how we might integrate with that and automate configuration of DNS through a project like external DNS and their DNS provider. Integrations with F5s are sort of challenging, although there are APIs. In my experience, the customers we spoke to are looking
for some degree of autonomy, and they're trying to avoid unnecessary interactions with the teams responsible for the F5s, because those can be long. However, if we could automate provisioning of VIPs on F5s, or if we could imagine that in every environment that workloads were deployed, there were an SDN. There's a lot of value in provisioning infrastructure load balancers on demand, as opposed to trying to manage this, trying to do everything in a platform routing tier. I'm thinking about TCP routing and port management in particular. But that's not reality. And we know that there's a tremendous amount of customers who are running on premises. They may not have an SDN, they may not plan to use one, and they still need, and they can't automate those F5s. So if only for those customers, there's a big opportunity to deliver value with a platform routing tier. And even in the case where everyone operated in a public cloud or had an SDN, we can't expect that those infrastructure load balancers are fulfilling all the use cases that app developers require, and that ingress routing tier and the service mesh are able to provide a lot more flexibility.
And if I could just add one thing, like the Istio is still pretty young as a project, right? So there are a lot of integrations that will happen in the future. So even if it doesn't exist today, I bet someone's thinking about it. I think we are at time. But if you had a question, we'd still love to hear it. So we can stay here and answer any additional questions. Thank you all for attending our session.